Well, welcome back a third time. We're in section 8.6. We've seen a video with standard conic forms. We've seen a video completing the square. And now this third part will look at some applications of conic sections. So let's get started. Number 5 says, find the equation of the ellipse and use that equation to find the missing coordinates to the nearest tenth. So you have some missing coordinates here. Be a little comma there. Sorry, it didn't show up very nicely. So we're looking for this missing coordinate. We'll do that together in the video. And then this missing coordinate I'll have you do as a try this. So let's write the equation of this ellipse. First thing to note is where the center is. The center is 2, 3. And then the next thing to note is this length is 1, 2, 3, 4, 5. Since this is a horizontal ellipse, the standard form would look like this. So the major axis would be horizontal, making the a value 5. And then we can count up this way. This would be the b value would be 3, where h and k are the center. So writing our equation of our ellipse, we would have x minus h is 2, squared, over 5 squared, plus y minus 3 squared over 3 squared equals 1. So to find the first coordinate that we're looking for, which is this one up here, this is when x is 4, what does y equal when x is 4? So all that we need to do is plug in 4 into this equation for x. So we're going to plug a 4 in here. And then we're going to solve for y. So let's do that. We would plug a 4 in for x. So we have that. That would be 2 over, no, that would be 4 over 25. 2 squared is 4 over 25. Plus y minus 3 squared over 9 equals 1. And then we need to isolate and solve for y. So we'll subtract 4/25 from both sides. Let's see, 1 minus 4/25 from that. That would be 25 over 25 minus 4 over 25, common denominator, so that would be 21 over 25. And then to isolate y, we should maybe multiply both sides by 9 to get rid of that 9. So 21 times 9. We get y minus 3 squared equals 189 over 25. Got that by multiplying both sides by 9. And then we can take a square root of both sides. So we get y minus 3 equals plus minus square root of 189 over 25. And then add 3, we get y equals 3 plus or minus square root of 189. Square root of 25 is 5. So it looks like our answer would be 3 plus that. So I got 5.75, or 3 minus that, y equals 0.25. So based on the graph, it looks like the y value that I'm looking for is either this one, yep, that's the one, 5.75. If we wanted the other y coordinate that's down here, that y coordinate would be the 0.25 that we found. So notice there are 2 times when x equals 4. So this is not a function, since it does not pass the vertical line test. There are 2 y coordinates for a single x coordinate. But we wanted the top one because we asked you for that point up there, so there it is right there. What I'd like you to try is the heart right here. As a Schoology try this, find the x coordinate when the y coordinate is 5. Now let's look at the second application or word problem. The main cables of a suspension bridge are 20 meters above the road at the towers. So that would be these at the towers is 20 meters above the road. This line here represents the road. 4 meters above the road at the center, so that's a height of 4. The road is 80 meters long, so that's 40 on the left of the center, 40 on the right of the center. The main cables hang in the shape of a parabola. You can see right here the parabola. That's the parabola we have. How long is a vertical cable 20 meters from the center? That's this one right here. What's the height or what's the length of that cable? Now, based on the graph, it looks like it's somewhere between 5 and 10. So whenever we get our answer, the length of the vertical cable, the answer should be somewhere between 5 and 10. But let's find the equation of the parabola. So a standard conic form for a parabola opening up is x minus h squared equals 4 times p y minus k. Now in this picture, we're told what the vertex is. The vertex here is at the point 0, 4, because we were told it's 4 units above the center of the road. So 0 is h, and k is 4. And we just need another x, y coordinate. So we could use this point. We were told that it's 40, or we could see from the graph that it's 40 to the right of the center of the road, and then 20 units high. So 40 is going to be our x, and 20 is going to be our y. And then we can find the value of p, and then we will know what the equation is, and we can answer the question. So we have 40 minus 0 squared equals 4 times p, 20 minus 4. So that would be 1600 equals 4 times p times 16. Divide both sides by 16, and we get p is 25. So that means our general form for the equation is x minus 0 squared equals 4 times p is 100, y minus 4. I've left x and y as variables so that we can plug in to answer the question. So when the cable is 20 units away from the center, what is the y coordinate? So when x is 20, what is the y coordinate? And that's what you'll be solving. You can solve that right now if you'd like. That's what you'll be solving as part of your try this. Let's look at our last question. The outer door of an airplane hangar is in the shape of an ellipse, more specifically a half an ellipse. So here you can see the ellipse, where this line is the ground, and then the plane would be going into the ellipse like that. The door is 40 feet across, so this distance is 40. We have it graphed there. It goes from -20 to +20. That's 40 feet across. And it's 10 feet high. You can see that here. It's 10 feet high. Find the equation describing the door's shape. So we'll do that first. And then we'll answer, or I'll have you answer, if you're 6 feet tall, how far must you stand from the center of the door to keep from hitting your head? Now, obviously, if you're walking through, you're not going to need to calculate an ellipse, but there are maybe more relevant questions like how tall of a plane, or what's the height of the plane at a certain point to make sure the plane doesn't smash into the hangar. So to find our equation, this is a horizontal ellipse. Now, the fact that it's a half of ellipse isn't going to be that big of a problem. It's not going to change our formula at all. We'll just recognize we should only have positive values for y. All the negative values are not relevant in this context. So our general equation for a horizontal ellipse is x minus h squared over a squared plus y minus k squared over b squared equals 1. So it looks like we've nicely positioned the center of the ellipse at 0, 0. So h and k are 0 and 0. The a value would be the horizontal distance from the center to the edge of the ellipse. So the a value appears to be 20. So that a value is 20. And the b value would be from the center up to the top on the half the minor axis. So our b value would be 10. So plugging those numbers in, we'd have an equation x minus 0 is x squared over 20 squared is 400 plus y squared over 10 squared is 100 equals 1. So this would be our equation of our ellipse, representing this airplane hangar. And you're asked, if you are 6 feet tall, how far must you stand from the center? So if you're 6 feet tall, 6 feet tall is this line that we have graphed here is the 6 foot line. You can see right about here it's passing through 6 foot. So it looks like how far from the center is going to be roughly, let's zoom in here, roughly somewhere between 15 and 20, but much closer to 15. So we're looking for this x coordinate. So when y is 6, what is the x coordinate? So that's what you'll be solving when your height is 6 foot. What is x, which is the distance from the center. So that is your last try this. Thanks for watching this video. I hope that that was helpful, and I hope that seeing some applications of ellipses and parabolas helped you put a little more context of why we might be interested in these various things. Thanks for watching this video. I'll see you next time.